Good afternoon and welcome to the sixth flight test of Starship. It is currently 3:25 p.m. Central Time at Starbase, Texas, and it has been just 40 days since our last launch of the world's biggest rocket. We're targeting our first afternoon Starship liftoff just 34 minutes from now, and that will occur at 4 p.m. Central Time. Now, this timing will bring us daylight views of the ship splashing down on the other side of the world. I'm Kate Tice, Senior Quality Systems Engineering Manager here at SpaceX.
And I'm Jesse Anderson, a Senior Structures Engineering Manager, and we are joining you live from SpaceX Hawthorne. On Flight 5, we promised you maximum excitement, and Starship delivered in what had to be one of the most memorable moments in my time here at SpaceX.
Same.
Like so many of you, we were in utter shock as we watched that historic booster catch unfold, and we're back today to try and do it all over again. As Kate mentioned, it's been just over a month since Flight 5, making this our quickest turnaround yet between Starship flight tests. Our ultimate goal is to get that turnaround time down to hours.
Following Flight 5, the SpaceX team went to work, immediately implementing lessons learned into the vehicle and tower's hardware and software systems for Flight 6. This is what rapid iteration looks like. We gather real data from these test flights and turn around and fly again as soon as possible. This is the process that is bringing us the rapidly reusable Starship that will soon be taking us to the Moon and Mars.
Flight 5 proved that we can safely bring the booster back to the launch tower, which is a key factor in driving rapid reusability, and land ship with a high-precision splashdown in the Indian Ocean.
This place is where our future is being built, and that is a future that we are all very excited about. All right, let's dive deeper into the inner workings of Starship and learn more about this flying skyscraper.
Starship features two major parts, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Now, just like Flights 1 through 5, the current iteration of Starship is an experimental vehicle flying for development. And with a few planned upgrades, Starship will have 3 times the thrust of Saturn V at 10,000 metric tons of thrust, plus the added benefit of full reusability. Starship 2 will be capable of carrying more than 100 tons to orbit, and Starship 3 will be able to lift more than 200 tons to orbit. Now, the amount of mass we're able to launch per rocket is crucial to creating a self-sustaining city on Mars.
Exactly. And speaking of launch mass, we should probably acknowledge the elephant, banana in the room, and our today's secret payload.
Okay, so 2 things here. The first is, remember on Flight 5, we had a giant Mechazilla decal where the banana is today. And there you can see that on your screen. Now, that decal is 3 feet tall, which might be hard to tell looking at it on the ship right there, which is why we have a full-scale reproduction of that decal here with us so that you can see the size compared to humans.
Yeah, it is bigger than you think it is. Like Jesse said, it's 3 feet high, and this is full scale, just like the one that was on Flight 5. Now, it is hard to follow Mechazilla, but I do have one better. Bananas have been used for quick visual comparisons for quite some time, and our teammates thought it was time to bring the venerated yellow fruit to Starship.
Today, we're flying Starship's first ever physical payload, which is, as you might have guessed, is a banana.
That's a live view inside Starship, and if you look closely, you can see our stuffed banana payload, which is doubling as today's zero gravity or zero-G indicator. And while this payload will remain inside the vehicle at all times and will not be deployed today, it did give us a chance to do a test run of payload approval processes with the FAA. And that's something that we're hoping to do next year if we start flying our first Starlink satellites on Starship. Godspeed, banana.
Some additional size for context, you can see on your screen a Starlink Mini next to a banana for scale. And to get an even better sense of how big Starship is, let's take the average size banana next to the average size human, which is about 2 meters high. Towering over our average human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket with the payload fairing attached is double the size of the Millennium Falcon at 70 meters, and nearly twice the size of that is the fully integrated Starship at 121 meters tall. The ship is about 50 meters, and the Super Heavy booster alone stands 71 meters tall. And we do have plans to make the ship and booster even taller in the future.
And yeah, it might be hard to imagine that because it's pretty big already. Now, Starship's first stage has a diameter roughly 2.5 times that of Falcon 9. And as you can see on your screen, with 33 much larger Raptor engines. I love this view. This is looking up at the aft end of Starship there at the engine bay. Now, moving up the rocket, the ship features 6 Raptor engines, 3 sea levels and 3 vacuum engines, which are optimized to operate in the vacuum of space. The ship is designed for vertical takeoff and landing on any hard surface, like the surface of the moon, for example. This ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing.
To reach full reusability, the ship must survive reentry not just once, but multiple times. It took the teams at SpaceX about 3 years to develop the heat shield on Starship, and development for improvements is still ongoing. The ship's heat shield is composed of thousands of hexagonal ceramic tiles designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit or over 1,400 degrees Celsius. The tiles are something we iterate on every flight test as we build towards a heat shield requiring no refurbishment between flights to unlock rapid reuse.
And the teams have actually already begun testing the heat shield tiles in environments simulating Mars atmospheric entry conditions, which we'll see more of in just a few minutes. You know, slightly different than coming back to Earth.
Just slightly different. And in between the first and second stages is our hot stage, which we saw in action on flights 2, 3, 4, and 5.
This will mark our second attempt to catch the Super Heavy booster at the launch tower, as well as
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Vehicle is pitching downrange.
Booster Raptor, chamber pressure nominal.
Booster and ship, avionics, power, and telemetry nominal.
All right, we're just a little over a minute
maximum
into flight.
Dynamic pressure.
We're about 6 miles away, so all the sound's still hitting us here. Hearing good call-outs that power telemetry nominal, that's flying straight and true. We do see all 33 Raptor engines lit up on telemetry screens. At this point, we've passed through that point of maximum aerodynamic pressure, that max Q. Now coming up in just a little over a minute from now is going to be hot staging. So we're going to see the 6 engines on the ship ignite while still attached to the booster. Just before that, we'll see all but 3 center engines on the booster shut down. In what we call MECO, it's most engines cut off instead of main engine. And so while we continue to watch it go up, a lot of our flight controllers looking at all the systems around the tower. Again, we have to send a manual command. Just about 30 seconds away from hot staging. And we heard the tower is go for catch.
Booster engine cut off.
The return flag is set for true.
Ship engine start up. Stage separation.
All right, hot staging confirmed. 6 out of 6 lit on the ship. Booster boost back going. We heard that we are go for catch. Kate, Jesse, take out the views. Hopefully I got a booster. coming home real soon.
Wow, from our view here, Dan, great views of planet Earth behind that super heavy booster. Right now it is performing the
Ship
boost
chamber
back
pressure
burn.
nominal.
Good news there, telling us that the pressures inside the ship are good. That is the second stage, or the upper portion of the vehicle. Follow along with the telemetry on the bottom of your screen.
Yeah, booster is currently, super heavy is currently in its boost back burn. This boost back burn,
Avionics, power, and telemetry nominal.
this boost back burn lasts just a little bit over a minute. So we've got a little, approximately 30 seconds left.
We've had shutdown of that boost back burn. Up next will be hot stage jettison. The view from the camera on the left, or from the booster on the left-hand side of your screen, and then tracking cam there on the right-hand side of your screen. We'll see those grid fins.
Booster offshore divert.
And we can also see that the hot stage has been jettisoned.
Yes, visual confirmation of that there on your screen, which is great. Now the next
Starship is following a nominal trajectory.
The next step for booster is going into that landing burn. Again, it'll light up 13 of those engines and then pare down to 3 engines right before booster catch.
All right, now just real quick, we did hear the call out, booster offshore divert. Unfortunately, that means that we are no-go for the catch. As we said before, both the tower and the vehicle, as well as the operators on console, have been actively evaluating the commit criteria for that return to the launch tower. And unfortunately, we did not have a pass on those commit criteria. So we are no-go for tower catch.
And we did mention that we're constantly evaluating the criteria for catch. There's a lot of things that need to go well in order to line that up. Unfortunately, today we will forego booster catch today. But what you're seeing on your screen is ship currently making its way towards the Indian Ocean, still looking good so far.
Exactly. So views there of the booster on the left-hand side of your screen, views of the ship on the right-hand side of your screen. Now, we said before that it was not guaranteed that we would be able to make a tower catch today. So while we were hoping for it, like we said, it was pretty epic on attempt 1, but the safety of the teams and the public and the pad itself are paramount. So we are accepting no compromises in any of those areas.
Exactly, and we're still going to get a lot of good flight data with booster even, but especially with ship. Again, we have an additional objective today to do an in-space relight of a Raptor engine, which again will help us set us up for being able to do deorbit burns, which is
Ship chamber pressure is nominal.
which is important for orbital flights. And what you're seeing on your screen is a view from Super Heavy as it's making its way back down to Earth.
Yeah, once again, we are attempting an offshore landing of the Super Heavy booster. So we have seen this before, and it is still very fun to watch, watching it come down for a soft splashdown off the Gulf Coast of Texas. We can see it there re-entering. We saw earlier those grid fins. There are 4 hypersonic grid fins. Oh, we can see that the landing burn has begun on the Super Heavy booster.
And same pattern, 13 engines will light, gone down to 3 just as we expected. And what an incredible view of splashdown that we got today of Super Heavy.
Yeah, I'm sure the buoy cam views will be pretty awesome once again. So we'd like to confirm a water landing once again for the Super Heavy booster. Congrats to the SpaceX team for making that milestone as well. Now, ship continues to look good. We can see that it is, while all of that was happening, the crowd here in Hawthorne continuing to react to all these amazing views that we're getting. The next milestone is...
Starship is in terminal guidance.
Great news there. Starship terminal guidance, referring to what we see here on our screen, the upper stage, at about 8 minutes, 35 seconds or so, we have ship engine cutoff, which will be the cutoff of the Raptor engines. We can see on our screen ship giving us some incredible views brought to us by Starlink. This view is also very interesting because we can see basically the receding tile line that we referred to earlier, where we mentioned we have removed a number of heat shield tiles in order to test out and push the envelope on the ship and demonstrate what its capabilities are.
Ship engine cutoff.
And there we just heard call out for SECO, ship engine cutoff. Great news there, everything continuing to look awesome for ship.
Full view looking aft on ship here.
Ship FTS is saved. Nominal orbit insertion.
There's that call out we were waiting for. Confirmation of good orbital insertion for ship today. Welcome back to Starship's 6th test flight. It has been an exciting day so far. We lifted off from Starbase at 4 p.m. Central Time. The Super Heavy booster and ship had a successful separation as well as a good boost back burn and good separation of the hot stage adapter. We did not attempt a return to the launch site and catch attempt today when strict criteria were not met and the Super Heavy booster executed a planned divert to a landing burn and soft splashdown in the Gulf of Mexico.
Yeah, obviously we were hoping to come back to the tower, but this was a test and we knew that it was a very viable possibility.
Starship is at 85 kilometers. Flaps now have control of the vehicle.
All right, great news there, turning our attention over to the star of the show here, giving us these amazing views once again. We heard the call out there telling us that the Starship vehicle is now 83 kilometers above, coming up around T plus, well, now actually, the ship, as you can see, is beginning to re-enter the Earth's atmosphere. As a reminder, one of the main goals of today's flight test is for the ship to make it through the extreme heat of reentry and to do so in a controlled manner. Now, reentry is typically a portion of flight where we don't have communication capability with the spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or about 5 miles per second. Now at those speeds, yep, pretty fast. The spacecraft is moving through the atmosphere rather quickly, and that results in friction, as we can see that starting to happen on our screen, and this creates a plasma field around the vehicle. That blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. The call out that the vehicle is transonic around T plus 1 hour and 2 minutes or so. That means that the vehicle is traveling near the speed of sound. We say near the speed of sound because there are certain parts of the vehicle where airflow is going faster and other parts where it's going slower. So it kind of teeters there on the brink of the speed of sound. So once we have equal flow on all parts, then we'll hear it's subsonic.
Yeah,
and almost real quick, almost a reverse of, I'm sorry, Jesse, almost a reverse of before. We see the Earth starting to come into view. We've got sunrise there over the Indian Ocean. So this is going to look different from any of the reentries we've had before. And it was specifically so like we get as much daylight as possible to see how ship does this. Over to you, Jesse. Sorry about that.
Dan, great minds think alike. That's exactly what I was going to point out, is that we're getting a lot clearer view of the Earth in the background with the different temperatures that we're seeing with the different colors of that plasma around the ship, which is really, really cool to see. Again, we are pushing the limits of ship today, but so far everything is looking pretty nominal. We'll see how the next few minutes goes.
Yeah. Like we've said before, don't be surprised if this is not entirely smooth sailing all the way down to the ocean's surface. Similar to Flight 5, we are targeting the same splashdown location in the Indian Ocean, but we are not expecting to recover the vehicle.
Right, and we were getting some glimpses of the flaps. The flaps so far are looking pretty good. We're not seeing any burn through. There's those flaps again. In that hinge area, which is our most concerning area there. That's great news for us for now. Again, the next few minutes could change as we continuously push those limits.
Yeah, once we slow down a little bit, once we're subsonic essentially, so I think that's about 1,200 kilometers an hour. Once we're down below that, that's when we're gonna kind of dip our nose down and get that more aggressive angle of attack. Normally we're just belly flop right into the water, pretty much that position. But if we're gonna be able to do return to launch sites, we're gonna wanna be able to fly with a little bit more of an angle of attack, get you a little bit more range as you're coming through. And so this'll be just a test to see quite how far can we push it. And obviously we're gonna do these kind of tests way out here in super remote areas before you ever try to bring a ship back to a place like Starbase.
Starship remains on a good entry trajectory. External temperatures are coming down.
And you can also see the graphic in the bottom.
Starship is slowing down past Mach 1.
And call outs aligning with this, you can see the orientation of the vehicle starting to change. You can follow that graphic at the bottom of your screen. Again, that is why those flaps are changing. They control the orientation of the vehicle.
Yeah, there are four.
This is,
Go ahead, Dan.
Starship has started the subsonic belly flop, remains on a good trajectory.
I was gonna say, this is when things will start to get a little interesting. So this is when we're moving slower than the speed of sound. You can see that nose slowly start to tip down, and we're gonna try and maintain flap control the whole way. But we are just a couple minutes away from hopefully doing a landing flip and landing burn if the flaps can hold together.
Yeah, this is such a cool view. This reminds me of when we first performed the belly flop maneuver on the high altitude test with serial number 8. We saw the ship come back through, and I always wondered what it looked like from the ship's perspective, and this perspective, I think, helps inform that. We will be, as Dan said, we will be dipping down a little further and really be flying nose first. This higher angle of attack, you know, we're intentionally doing it to stress those aft flaps, and that will help inform the limits of flap control in order to collect data for future landing profiles.
I mean, we're looking good so far. We've just got about 5 kilometers in altitude to go. We'll ignite the engines when we're still just a couple hundred meters over the ground, do that flip.
Starship is passing through 5 kilometers altitude, remains on a good trajectory.
I have a feeling this is going to look so cool as it passes through the clouds.
Obligatory shout out to the entire avionics team on Starship.
And there's that nose down orientation.
Now the Raptor engines will relight and help flip the booster back up. This is a more severe flip given the orientation. The engines will shut down prior to the water making impact, prior to the vehicle making impact with the water.
Our ship is doing great so far. There's those engines relighting.
What a great reorientation by Starship.
Wow.
All 3 down to 2 into the water.
Starship is landed.
Wow.
And we have ship splashed down in the Indian Ocean.
Some awesome buoy cam action here. Daylight views.
Incredible. We really pushed the limits on shipping and made it all the way back down to Earth.
I am shocked, to be honest. I think many folks are. The fact that it survived all the way through while flying a lesser gen heat shield is just absolutely incredible. And turns out the vehicle had more capability than our calculations predicted. And that is why we test like we fly.
Exactly why we do that. And those views were absolutely incredible to watch. Because of Starlink, we were able to get the views all the way down, as well as the buoys, seeing ship touchdown in daylight.
So cool, so cool. Now we want to, unfortunately, wrap up the show.
Yeah, exactly. We'll say congratulations to our teammates at SpaceX and to everyone who supported the Starship program. And thank you to all of our future customers for your support.
We'd also like to thank the people of Cameron County, Texas, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and the Australian Space Agency.